From escaping from the evil aliens on the USS Enterprise to operating low-orbit satellites, the ion engine has been a staple of high-efficiency space travel since the 1960s. On today's episode of How Ion Engines Are Made, we are going to take a look at the humble beginnings of the ion engine. This top-secret facility, which produces the cutting-edge ion engine technology, is where we will be studying today. This crack team of engineers is looking to send their ion engine into space. Dr. Camburn is the sponsor who runs the lab. This is how an ion engine works. Gas enters the chamber. An anode strips the electrons from the gas. The gas is then attracted to the cathode ion grid, but due to its accelerated speed, it misses and shoots out the other side, thus creating thrust.
Oh hey, you guys are here already. Let me show you around. Welcome to the lab. So, as you guys probably already know, we're working on an ion engine, and there's a current prototype that we've been using in the vacuum chamber here, and it currently runs on outside power sources and gets its air from this room, just from vacuum pressure. And it's pretty complicated. It's got a lot of parts in it, and there's a lot of work to do in the lab. So one of those things is trying to make the engine a bit more simple, less parts, and we're also trying to make it so that the electrical system is more simple and compact. That way we can have all the electrical systems on board, so it's not connected to the wall. The reason being is because we're trying to launch a flight weight prototype that can go up in a rocket. So obviously it can't be connected to a wall. And then there's lots of smaller things around that we're working on in the lab. One of the things we're trying to do is convert to 4 grids instead of 2 grids. We're doing this for testing purposes to see if it improves our efficiency. And we've made some prototypes in the past, and I'll go through them real quickly and explain the thought process behind those ones. This prototype is the sandwich design. It copies the current prototype's design, and then we have this replica design. It's pretty much the same as the original design, and it has a couple extra grids added to the front. This is the clamshell design. This design allows for the grids to be clamped in, and finally we have the slotted grid design. These all laid the foundation for our future thought process and prototypes. And here, let me show you some of those now.
Oh, hey guys. Well, what am I working on here? Currently, this is our newest prototype for our power system. Previously, we've been using a bunch of neon sign transformers to up the voltage from the wall outlet to the grids inside the vacuum chamber. But if we are going to be launching something lightweight and flight ready, we need to have an on-board power system. So the team realized we can't be using neon sign transformers. So after looking around, we realized that tasers can actually achieve a similar voltage to what we're looking for, about around 50 kilovolts. So the team went out, bought a taser. We completely gutted it, took out the transformer, the little controller chip, and hooked it up to a battery. And what we're doing now is just seeing if this prototype can function as a power source for an ion engine. It's a very preliminary prototype for an ion engine, but hopefully it works.
Go.
Another thing we've been working on, just sort of a side project, is changing the material that the ion engine stand uses. So previously, it was made out of metal. which was not working well because we had current arcing from the ion engine to the actual stand, ionizing gas outside of where we wanted it to ionize gas. So the team said, hey, what if we made something out of wood? You can kind of see the holes that we drilled through these pieces to accommodate this part here. However, after looking through it and realizing that porous material does not actually operate in low pressure super well, creates extra particulates, could damage our turbine, we decided to make another iteration out of plastic. This should be safe to use in the chamber, and as you can see, it fits the previous mounting pretty well.
Oh, hey guys. I'm working on this part right now. So this part is called the housing grids. So basically, the previous model, they are using 2 grid system, but our group have redesigned for the 4 grid system housing. So as you can see, this part is the first model that we created by 3D printed. So this part is based on the CAD model dimension, but our team have a problem with this because it cannot fit the grids, because it seems like the dimension is all wrong. So our team decided to measure from the current prototype, as you can see here. So we measured the diameter and the grids, legs, everything. So we come up with the new model, which is this one. So this one basically can fit 4 grid system. So you can fit the grids by inserting and sliding through this hole like this, and then you can repeat it by putting the spacer between it, and you can put another grid through like this. So you can repeat it by 4 grids. So the last part is this one. So this one should be the cover for the top one, like this. So this part can make all the model. This model can isolate the wire from the air. So if we connect the wire at the end here, this part is used to cover all the grids and everything. So hopefully this model will work for us. Okay, thank you.
Oh, hi guys. You guys made it to the end of the tour. We briefly walked you through our project scope and the current work we've been doing in the electrical side of things and in the CAD work side of things with the 4-grid module. Some challenges we are facing is that the launch conditions that we'll be seeing are way different than what the current prototype has been seeing inside this vacuum chamber. So we need to do a lot of research in that, since air breathing ion thrusters are kind of the new frontier of space travel. For future work, we still need to continue iterating the 4-grid module design to fit the grid that the previous prototype was using, since we'll be reusing those grids. On the electrical side of things, there's still a lot of work to be done there. As you saw, we are currently working with tasers, and we haven't been getting the best results there, so we might move on to something different to make it possible to have an electric onboard system for when we launch. And other than that, there's still a lot to be done, but we'll make sure to keep it done and keep you guys on track.
We hope you've enjoyed this episode of How Ion Engines Are Made. Special thanks to viewers like you. Thank you.